Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0722, indicates a problem in the output shaft or countershaft speed sensor circuit due to a lack of signal input. This issue is critical for the function of the vehicle's automatic transmission, AT. The output shaft speed sensor is located on the transmission housing and is responsible for measuring the rotational speed of the output shaft, which plays a vital role in the vehicle's shift control strategy. A malfunction in this sensor can lead to improper shifting, reduced fuel efficiency, and overall impaired vehicle performance. Typically, this code surfaces when there is an electrical failure in the circuit rather than a mechanical issue within the transmission. Before proceeding with troubleshooting, it is essential to document all freeze frame data and snapshot information using the Honda Diagnostic System, HDS. The output shaft speed sensor measures the rotation speed of the output shaft, which is crucial for the transmission control module, TCM, to optimize shift points. This sensor directly influences the engine's performance, fuel economy, and shifting behavior. Typically located at the transmission assembly, this sensor provides real-time feedback about speed to the powertrain control module, PCM. This feedback is essential for the transmission to function smoothly and efficiently. If the sensor fails or its circuit encounters issues, it results in erroneous or absent speed readings. Understanding the role of this sensor helps in diagnosing issues and determining the appropriate fixes. The primary causes of DTC P0722 involve electrical circuit malfunctions rather than mechanical failures. This could stem from damaged wiring between the output shaft speed sensor and the PCM. An open circuit would prevent the necessary voltage signal from reaching the sensor, leading to no signal input errors. Additionally, a faulty output shaft speed sensor could itself be the issue if it fails to generate a signal despite having power. It's also essential to consider any poor connections or corrosion that may disrupt the electrical flow. Understanding these causes allows for targeted troubleshooting and ensures that the most likely issues are addressed first. When experiencing issues identified by DTC P0722, one may notice a variety of symptoms related to transmission behavior. Erratic or harsh shifting can occur, leading to a less smooth driving experience. Poor fuel economy is another common symptom, as improper shifting can decrease efficiency. Additionally, you may observe general performance issues with the engine, as the lack of proper input from the sensor causes the PCM to make incorrect adjustments to engine operations. Here, it's vital to pay attention to both subjective driving experience and the diagnostic codes when troubleshooting, as these symptoms give valuable clues about the underlying problem. The first step in troubleshooting DTC P0722 is to turn the ignition to the on position, or I, without starting the engine. Once powered, use the Honda Diagnostic System HDS to clear any stored diagnostic trouble codes. It's crucial to record freeze data, which contains valuable information about conditions during the failure. This data can include vehicle speed, engine load, and other pertinent parameters at the time the DTC was set. Analyzing this information will provide better insights into why the fault occurred and help in subsequent troubleshooting steps. Recording freeze data is essential as it helps establish a baseline for further diagnostics. In the second step, ensure the rear wheels are blocked to prevent any unwanted movement during testing. After securing the rear wheels, lift the front of the vehicle, making sure the vehicle is adequately supported, either with jack stands or a lift. This precaution is pivotal for safety during the diagnostic process. Allowing the front wheels to rotate freely helps simulate real driving conditions, enabling you to assess the output shaft speed sensor under load. Properly executing this step is crucial for accurate readings and avoids any risk of injury during the testing period. This lays the groundwork for the next troubleshooting steps, ensuring the vehicle is in an appropriate position for effective diagnostics. Next, start the engine to proceed with the actual testing while ensuring the vehicle is still safely raised. Disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. This step is necessary because VSA may interfere with the readings needed to assess the output shaft speed sensor. After disabling VSA, shift the vehicle into Drive, D, and allow the engine speed to rise above 2,000 RPM. Monitoring the speed at this point is critical for comparing the output shaft speed against the input shaft main shaft speed as displayed on the HDS. This comparison underlines the function of the output shaft speed sensor. Any discrepancies can signify a problem that needs further attention. Ensuring these conditions are met is essential for the success of subsequent troubleshooting steps. Once you have the engine running and the vehicle in the appropriate gear, compare the output shaft speed and the input shaft speed using the HDS. If the readings show similar speeds, it indicates that the system is operating normally at that point, and the issue might be intermittent. Such intermittent failures may not always trigger a DTC, but can cause erratic operation. If the speeds differ significantly, that indicates a failure in the system requiring further investigation. This step is crucial for distinguishing between a functional sensor and an intermittent issue that may require deeper analysis. Each reading reinforces the understanding of the sensor's operational integrity. In this step, securely turn the ignition switch to the lock position, 0, to ensure safety before any disassembly. After securing the ignition, disconnect the output shaft, countershaft, speed sensor connector, ensuring that the electrical connection is clean to avoid potential false readings. This action prepares the sensor for testing by eliminating any interference from the PCM. It's essential to prioritize safety throughout the process by ensuring that the ignition is off before any connectors are handled. Taking these precautions helps to avoid shorts or unintended system activation. Once the sensor is disconnected, you are ready for the next testing steps to determine the voltage levels and diagnose any potential issues further. After disconnecting the speed sensor connector, turn the ignition switch back to the on position. 2. While not starting the engine, use a multimeter to measure the voltage at terminal number 1 of the output shaft speed sensor connector, referencing it against the body ground. The expected voltage should be approximately 5 volts. This voltage is necessary for the sensor to function correctly. If the voltage is present and stable, it indicates that power is reaching the sensor, which is a crucial part of verifying its operational capacity. If the voltage is absent or significantly different from 5 volts, it suggests an issue with the circuit, likely an open wire between the powertrain control module, PCM, and the sensor. Understanding this step helps isolate electrical faults early in the troubleshooting process. With the ignition still in the on position, 2. Proceed to measure the voltage at terminal number 2 of the output shaft speed sensor connector, again, referencing body ground. The expected results may vary depending on the vehicle model year, where different color wires indicate different signals. For 2008 to 2009 models, look for a blue wire, while for 2010 to 2012, it would be a tan wire. A reading within expected ranges would affirm that the sensor itself is functioning properly. Conversely, If the voltage is absent or outside of expected parameters, there could be an internal fault within the sensor or failure in the circuit wiring. This step is vital for determining whether the sensor or its circuit requires repair or replacement. Mastering this diagnostic approach ensures comprehensive evaluation of component functionality. Once repairs are completed, shake all connections and reassemble the necessary components. Conduct a thorough test drive to ensure everything functions smoothly, paying attention to the transmission behavior. During the test drive, monitor the onboard diagnostic system to check for any recurring diagnostic trouble codes, DTCs. If all conditions return to normal, it indicates that the issue has been successfully resolved. Should the DTC reappear, this suggests that further investigation is necessary into the wiring or sensor being tested. Ensuring diligent testing at this stage confirms that all previous steps were accurate and that the resolution has fully restored operational integrity. Accurate verification is crucial for long-term reliability. Preventive maintenance can mitigate the recurrence of DTC P0722 by ensuring that both wiring and connectors remain intact and free from corrosion. Regularly inspect the wiring harness connections of the output shaft speed sensor, as any wear and tear can lead to signal losses over time. Ensuring all sensor connections are tight and contamination-free can prevent electrical issues from arising. Utilize updated diagnostic tools, such as HDS software, to conduct routine checks on diagnostic codes. Such proactive approaches promote the longevity of the sensor circuit and improve overall reliability of the vehicle's transmission system. Addressing potential problems before they escalate into serious faults can save time and resources in the long run. To summarize, DTC P0722 indicates a critical failure in the output shaft, countershaft, speed sensor circuit due to the absence of signal inputs. Proper diagnosis is essential, as this code can have significant implications on transmission behavior and overall vehicle performance. Key steps involved in troubleshooting include verifying voltage levels, checking wiring integrity, and understanding the critical function of the speed sensor. By maintaining rigorous standards during inspections and employing preventive measures, vehicle reliability can be greatly enhanced. Always document findings and proceed methodically to ensure accurate results for effective vehicle performance management. Awareness and proactive maintenance play a significant role in preventing sensor failures. Please like and subscribe to the channel. See you next time.